Everybody. All right, I've started, guys. So, which for the session, please. You guys can have the video. All right. So, we're working through this paper. Let's see this video. This is how you to learn from the mistake. Not repeat the mistake. After that, this paper started already online. That's the live. But it's just for what to do better than to go watch everybody. You have to have this paper filed online. There's no problem. I do it again. Maybe I'll take your question. Whatever the question is, you don't want to clarify. And I'm not asking to do it. All right? Let's use your food. So, first question. Always is a calculator question. Oh, this one is kind of different. It says by rounding each number in the expression one significant figure. Normally the first use a calculator to work on the part. We really chop that. Right. So by rounding each of these figures, so one significant figure, you have to estimate the value of this. So these are the figures we need to correct to one significant figure. This one, this one, this one. So each of them to one significant figure. Now, the first significant figure is a number. The first non-zero value starting from left. For example, 108. And then the square root that. Don't please call it the square root that. We are rounding the figure. Correct, let's do this one decimal place. But the size of the number is the same here. This number is in 100. So this is the first significant figure. So that number actually becomes 100 if we correct it to one significant figure. But I can appreciate that. Then this one under here. This is the first significant figure, this 1. This 9 is correcting this one. Now, remember, this number now is now the tens. So it actually becomes 20. But the 9 increases this one. But the size of the number is in the tens, and that becomes 20. So when it becomes a 2, you replace this now with a 0. So that number to one significant figure now is 10. Plus, then this one now, this is the first significant figure. That number is in the 1, 5, and so on, right? So this 2 is correcting this 5. It does not increase it, so it stays 5. So this figure to one significant figure is a 5. That's what you reduce this to when you correct each figure to one significant figure. Then now we know that the square root of 100 is 10 divided by this becomes 25. Then we'll simplify this. Divide this by 5. We get 2. Divide by 5, we get 2. Divide by 5, we get 1. So, in simple terms, this is equal to 2. It is that. I correct them to 1 significant. How we can do 2/5 is actually 0.4, right? Because the same as 4 over 10 is 0.4, right? So we can check and see if this would work out to about 0.4. And let's see what we get. So to be a fraction, just to check it, to be a fraction, and remember we have the square root of 108. Now putting that over 19.72, and we are adding 5.296. This is 0.415. Approximately one decimal place that is still the 0.4. All right, which is the 250. So that's an acceptable answer. Right? So we can move on. If I go to that, the following instruction, most times the questions that use the character work. This one tells you to do something different. You have to follow the instruction. All right, so that's what they want to do. This is how many masters? 2 masters. This one now says you have to find the exact value of it. They don't tell us how to do. So we know use it. All right, and they say give you your answers a mixed number in the simplest spot. But because they didn't tell us to use a calculator, I might want to work it out and do a little step. So I see the steps in this one. Not because I never see the calculator, but you still can know. But just to be on the safe side, how many marks is? Because it's 3 marks, let me put some work on this one. You get me? I want to write this as an improper fraction first. We'll do that. The multiply by the 3 times the shortcut method, 4 plus 3 makes 27. But I get that? 27 over 8. It becomes 27 over 8. I go to that, right? And then we're dividing by, I want to make this into one fraction. I want to make this into one fraction. Remember, the following the order of operation, you're supposed to work what's in the bracket first. I think the term. All right? So what I do, I want to make the two of them of the same denominator. So this term in the bracket, let's work it out on the side. It's 5 over 12. It's 5 over 12 plus a third. This third multiplied by 4 over 4, it becomes 4 over 12. That's what this bracket term becomes. This bracket term becomes that. And then now it really becomes 9 over 12. Margaret, agree with that? But when you divide by 9 over 12, it's the same as multiplying by 12 over 9. You know that, right? Invert and multiply. And then because this 3 marks, I'm doing so much work on this one. Now I'm going to stop it in the calculator. But we can always put in the calculator afterwards. Make sure that we're correct. So let's just need to simplify now. So we can go up. 4 into this goes 2 times. 4 into this goes 3 times. Then 9 into this is 1 time, and 9 into this is 3 times. So the final result is 9 over 2. The question says must give the answer a mixed number. See that? A mixed number. So basically, it's 9 divided by 2. It becomes 4 remainder 1. It becomes 4.5. That's the answer. 4 remainder 1. We divide the 9 by the 2. So 4 remainder 1. So let's put this in the calculator now and see if we get the same 4.5. Let's just do that just to make sure. All right? So we don't want to give away marks on this. So it's 3 and 3 is. By the way, you guys got the same answer here that I have? Yeah? All right. So we can move on. So I got the same answer. Trust you guys. 1/3. Right, see that corner, right? So this is good. But they tell us to write as a mixed number, guys. Follow instruction. Follow instruction. So we leave 9 over 8, we might lose a mark in. Not have looked, not follow the instruction. Right? Follow instruction to see everything. That's the answer for that one. Next question down here. Need a calculator. Leave the calculator. It says, due to the COVID-19 pandemic, the number of available seats in a hall was reduced from 125 to 93. So take out some of the field, right? It says, calculate the percentage decrease in the number of available seats. So it is the decrease divided by the original amount that was there, multiplied by 100. It's important that you divide it by the original amount. All right, so it's going to be the decrease in the chairs divided by the original number. I want to know what the decrease is in relation to the original number, multiplied by 100 to get as a percentage. What's the decrease? It's 125 minus 93. 125 minus 93 is the decrease. Divided by the original number is 125. multiply that by 100 equals. I not even going to work it out part by part. Let's put it in the calculator. 125 minus 93 over 125 times 100 is 25.6. 25.6. That's a percentage decrease. That's a percentage decrease. All right, no, next question. Next question says, Mika invest a certain amount of money in a bank that pays compound interest at a rate of 2.5% per annum per year. At the end of 2 years, okay, so it was 2 years, so 2 years time in here. When this is per annum, you need the time to be in here. So this is 2. And this is your R, your rate percent. Right? So after 2 years, the value of our investment is this. So this is the final figure. This is the amount accumulated. This is the A, amount accumulated. Right? So what we don't know in this question is the amount that we invested. We invested a certain amount. We don't know that amount. That's called the principal amount. All right? You can calculate the amount you invest. That's the fee they're asking us for. This question is asking us for the fee. But this question gives us a formula. And this N right here is actually the T, the number of years. That's what that N is. This N up here is the number of years. So they tell us, they say A is the total amount after N years. See? N years. So the T, all we have as N is, but this is actually T. Right here. But let's change this to an N. N. And the best kind of question is asking us to find the P. That's the question is asking us to find the P. So to find the P, we have to transpose this formula, I mean, P the subject. So we have all other values enough. We have the R, and look here, see the R is going to be just 2.5, because the 2.5%, the percent part of the R is already taken care of by the 100 being on the year. So the R value is actually 2.5. All right. So in this question, I want to make P the subject. So to make P the subject, we can basically take all of this expression and divide it under the A now. But I can say that, divide it under the A. So basically then we can say that the P that we want is going to be equal to the A divided by all of this expression, which is 1 plus R over 100 raised to the power N. And put the values in that, I'll get the answer. Take all of this and divide it under the A to make the P the subject. That's all we have to do. That's P you want to find. But for that, the P you want. So we divide everything in this formula right here. This formula right here, we want to make P the subject. We take this in the bracket as an expression and divide it under the A. And that leaves P as a subject. And then put in the value here. So the A is the amount accumulated, which is 7564.50 divided by bracket 1 plus the R is 2.5 over 100 raised to the power 2, that the T is equal to 2. Put that in the calculator and get the principal amount invested. So put that in the calculator and you're good. The fraction, you must get a good calculator. 7564.50 over. Then here I'm going to put the bracket. I'm going to put the 1 plus fraction under here again. I'm going to put the 2.5 over the 100, putting it exactly as it appears here. Close the bracket, and that is a square. That's it. 7,200. 7,200 is the amount invested. Y'all got that? Good. 7,200, yes? Huh? It's a formula, Mama. If I give it to you, it's a formula to transpose and put in value. There's nothing to it. Once I give it to you, I want to give it the formula. I'm going to tell you, they don't give you the formula, the most of them give is a 2-year thing. And all you have to do, calculate the compound interest for the first year, that's the new value, and then calculate interest on that value for the second year. There's not more than 2 or 3. It's not complicated. You understand me? But if they give it to you, just as how they did here, they will give you a formula. Simple as that. If they don't give you a formula, just work out the total amount for the first year by applying the interest. You see that total amount that you get for the first year, you have a second year, you get interest on that new amount again for the second year. And if you want a third year, and you get the new amount for the second year, you get interest on that new amount for the third year. That's all you have to do. Compound interest. What? And the amount keeps growing. All right. You always apply the interest to the new amount each year, the accumulated amount. All right, good. All right, no problem. Let's go. This question says, I don't need the calculator now for this. This question is testing our knowledge of indices. So this one, they want us to simplify this. So when you raise a power to a higher power, you can actually multiply the power. You can multiply the power. So this answer is equal to x to the 3 times 2, which is x to the 6th power. Or this square here, so means that you're multiplying x cubed times x cubed. And when you multiply indices, you add the powers. So then it would then become x to the 3 plus 3, which works out to x to the 6th power anyway. And we want to do it, the power answer as x to the 6th power. Good. This second one here. When you divide indices, you subtract the powers. Note that this power is negative. When you divide indices, you subtract the powers. Once the base is the same, you subtract the powers. So this one will become y to the 8th power minus, this power is a negative 5. So this minus becomes a plus. So then it becomes y to the 8 plus 5, which results in y to the 13th power. That's the answer. Y to the 13th power. Simple as that. You add the powers. The minus becomes a plus. All right, the next one is for us to factorize this. So here we just have a common factor of y right now. Common factor of y. Then factorize out the y. Out of this, you're left with the x. Out of this minus y squared, you're left with a minus y. And then this can't factorize any further. So that is it. Very good. Next one. Factorize this. That's the difference of 2 squared. The most to know the root of the difference of 2 squared. This one becomes the difference of the numbers times the sum of the numbers. Them things are supposed to be basic by now. The difference of 2 perfect squares. That's it. Done. All right. Then here they say hence. The hence means that you use these 2 results. Those results on the first part to work this out. Now, what do we recognize? This numerator is this thing at the top, and this denominator is this thing at the bottom. So, as a single term, this thing becomes numerator as this one up here, which is y into x minus y over the difference of 2 squares here, which is the x minus y times the x plus y. What happens now is that the x minus y cancel each other. This x minus y and this x minus y, they cancel each other. So the final result is y over x plus y. That is the final result. Simple as that. Very good. Nice and easy. Next question. So add some algebraic, right? Some measurement. It says the diagram below shows 2 rectangles, M and N. So that's the M1, that's the N1. With their dimensions expressed in terms of x. So dimension on this one is x minus 3 centimeters. This one is 3x plus 4. This one is the x minus 3 via x plus 2. It says, given that the difference between the areas of the 2 rectangles is 64, it means that area here so minus the area here so is 64. Show that this expression is true. Find that expression. What I'm basically saying is that the area of M minus the area of N is equal to 64. But this is the bigger one. What is the area of M? This times this. That is x minus 3 times 3x plus 4. This is the area of the first one. Minus the area of the second one, which is this one now. Is x minus 3 times x plus 2. X minus 3 times x plus 2. That's equal to 64. What it means is that we need to take this expression and simplify it down to that. That's all that's going to happen. Multiple ways to do it. We can decide to expand out this part and expand out this part. And then simplify down the term. And this 64 will have to come over because they have a 0 on the right side. Or we can look at it and say, okay, this is a common factor. This x minus 3 is a common factor. So we can write these two as one expression. But we're going to expand anyway. So I think I'm going to use the approach where I expand this one and then subtract. All right? Let's expand this one first. So it's this times this, which is 3x squared. We're going to have a middle term. That's the shortcut. The middle term is the far product and the near product added together. Give me the middle term. That's a step up again. The far product and the near product, we have those pairs of brackets multiplying. The middle term is the far product and the near product added together. The near product is minus 9x, because it's minus 3 times 3x, that's minus 9x. The far product is x times positive 4, which is 4x. 4x and minus 9x is negative 5x. Everybody can answer that? My middle term is negative 5x. Let's go. That's negative 5x. Then my third term is this value times this value. 2n value, that's negative 12. That's in the first bracket. This gives me this. When I'm subtracting, I'm going to expand this the same way. Put it in a bracket. So this negative is applied afterwards. So again, it is x times x, which is x squared. The middle term again is the far product and the near product added together. The far product is 2x, and the near product is negative 3x. That is negative 3 times x is negative 3x. And this time this is 2x. So the negative 3x and the 2x is negative 1x or negative x. Negative x. The middle term is negative x. Then this negative 3 times 2 will give me that negative 6 equals 64. But good so far? We're step by step. We're going to subtract the like terms now, right? Pay attention. So this is minus. So we're using the terms in here, minus the terms in here. Careful with the negative sign. Let me cancel this now. So it's 3x squared minus x squared. But you answer that? That's 2x squared. 2x squared. Then it's minus 5x minus a negative x. That becomes plus x. So it becomes minus 5x plus x. But you answer that? That becomes a negative 4x. You have a step by step, fine enough. Okay. Step up our game on these things. All right? Like term. So that's a negative 4x. Then it's negative 12 minus a negative 6. That becomes a plus 6. Negative 12 plus 6 becomes negative 6. Negative 12 plus 6 becomes a negative 6. So we'll get a negative 6 right here. And then this 64, we're going to bring it over and put it as negative 64 equals 0. What are we going to do? So each of these values can be divided 2 by 2. I must realize that this is actually negative 70. Don't it? Negative 6 and negative 70. I'm going to simplify, divide 2 by a 2. Divide 2 by a 2. I'm going to get the expression that they said. This divided by 2 is x squared. This divided by 2 is minus 2x. This 70 divided by 2 becomes 35. Negative 70 divided by 2 becomes negative 35. And 0 divided by 2 remains 0. That is what they told us to show. Therefore, it's not only. Yeah, next step. Gotta go to that. All right. You know, step by step and write more lines, no problem. All right. You know, they don't give a lot of lines to work with, or go a lot of space. Huh? We get 35. So this and this are 70. It's out 54, 70, negative 70. Negative 70 divided by 2 is negative 35. All right. So you could have put negative 3 and negative 33. So negative 35. We have to learn to be efficient. All right, better go to that. All right, so the body must reach 80 marks so far and 2 questions there. That's why 45 marks. That's all it is. You get the right, you get the answer at the end. All right, you understand it now? This is a question I'm going to read. When the question you never get right, you see what you do now is that there's nothing to it. You know, question is not hard enough. You understand? I put it this way. If it's hard for you, it's going to hard for everybody. So don't worry about it. It's work. Any question you get wrong, it's going to be it over. If you get another one like it, do it same. That's what it's all about, you know. If you know ourselves, everything that we're exposed to, if they bring back anything like it in the exam, you want to be able to do it comfortably. It don't make no sense to have all of this available to us and we don't use them. Use them to the max. But once safety bring back anything similar to these, it's good to go. So that let it be that we spend time on brand new stuff. It's the brand new stuff. Get me? The more them we do, the more the brand new stuff will look familiar anyway. That's what it is. All right, let's go. This question actually gives some person some problem. Few times to ask. So kind of uncharacteristic. I would say ask this one as a special question. Few times to ask. That's good. The question says, following diagram shows three quadrilaterals P, Q, and R on a square grid. Q and R are images of P after underwent 2 different transformations. So this is the original one. It was transformed to this, which is clearly an enlargement. It was transformed to this, which is clearly a rotation. I would say the thing turn. All right, a rotation. No. Okay. But this one, the enlargement, if you're describing that enlargement, you have to give 2 things for the enlargement. Scale factor and the center. And for this one, from here to here, the rotation because the thing turn. So we have to give the angle, the direction, and the center. Now, most times with this question, the center of the rotation is the origin, but not this one. You have to remember the way how you find the center of the rotation when it's not just the origin. The key thing to remember that the center of the rotation, remember this guy, doing the top. Which on the point of intersection of each perpendicular bisector. So I go back and watch the video and make a note of it. Center of the rotation and the point of intersection, each perpendicular bisector. The line joining corresponding points and the image and the point. That's all you're going to find. Well, let's go to the question. That is the part that gives something a problem, right? Even some teachers have problem with this question. I don't remember. That's something that 50 don't get asked. For the past 10 years or more. So the first time I set a question was 10 times I wrote it, that was my home. Most times I said that was anytime you have a construct to find it, just remember. Once I put the section, 2 perpendicular of the line joining corresponding point. Well, let's go to the question. First thing they want us to do is they want us to do a translation on the triangle P of 10 negative 4. No, 10 negative 4 means 10 to the right and 4 down, don't it? So moving this, we're moving P, 10 to the right, 4 down. And it's not going to turn until the size and shape will remain the same. Just move from one location to another, right? So we can literally just move 1 point and then draw about the same shape around that 1 point. You can often do like that. You don't take that chance with reflection on some of the other ones, but translation, 1 point, and then draw the same shape around that 1 point. So we're moving this 10 units to the right and 4 down. So what's the first thing we have to do is make sure that each of these centimeters is 1 unit. I check that. And each of these is also 1 unit. You take the scale first before you start. Check it, because here, this is between 4 and 6. Each of these is 1. Right? So each of these is 1 unit. And then vertically, let's check that as well. Here, 2 units to 2. That means that each of these is 1. So we can move this point, for example, 10 to the right and 4 down. Let's count it out. All right? Pick way to do it. Like the construction. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to there. Or you can add 10 to this x coordinate right here. So it's -7. If you add 10 to -7, we're going to go over to 3, which is where this is. You see it? This is at 3. All right? Then we need to move it now 4 down. 4 units down. 1, 2, 3, 4. Another way to do it is that this y value, which is 7, and subtract 4 from it, it comes down to 3 right here. See that? At this point is 3, 3 actually. You could have calculated that point as well. But we have to do that to calculate and construct it. So this point now corresponds to that. So all we have to do now is draw at the same shape around that point. So 1 diagonal in that unit box, or that unit square. 1 diagonal in this unit square. And then we have 2 down, 1 back. That length of that diagonal all the way down here. And on this side as well. We get by the same shape. That is the image of this. We normally tell you to label it something. They didn't tell you to label it on anything. Let me see. It's a label it P prime. So this is P prime. What are we going to do that? Nice and easy. All right. So I'm going to take these off. I'm going to need space. All right. I'm trying not to give away marks on these questions. Next question. Next thing I want us to do is reflect CMP in the line y equals 0. Now, what you have to know is that the line y equals 0 is actually the x-axis. They're asking us to reflect in the x-axis. You have to know that the line y equals 0 is the x-axis. The line x equals 0 is the y-axis. All right? So that's actually the x-axis we're reflecting. Now we're going to reflect it in the x-axis. So the x-axis right here, reflecting that in the x-axis. Do the reflection 1 point at a time. Image distance equals object distance. All right? So this point, for example, is 1, 2, 3, 4. You're going to go 4 on the other side of the mirror line. 1, 2, 3, 4 to here. And this point is what? 1, 2, 3, 4, 5, 6. You're going to go the same distance on the other side. 1, 2, 3, 4, 5, 6 to here. And this one obviously is right across from it. This one is going right across from it. So we can put it right across over here. And then this one now is going to be 7. 1, 2, 3, 4, 5, 6, 7. I'm going to go 7 on the other side. 1, 2, 3, 4, 5, 6, 7. Don't be here. So those are the points. Those are the points on the image. You draw the line, join the point. So you have this one, use the roller and draw. Don't do it free-handed like me. This device I can draw straight to this line. I will not do this other halfway line. And it's a label this one, E double prime. E double prime. All right, that is that. That's supposed to be straightforward. Next thing. They say now we have to describe fully now the transformation which maps P onto Q. So P to Q is this one. Enlargement. Enlargement has a scale factor and a center. The scale factor is just to multiply by how much it grows. This one is a positive scale factor. I know it's positive, but pointing in the same direction. And the scale factor is a value greater than 1. All right, so we can use one dimension, for example, we can use across here. That is 2 units across. This is how many? 1, 2, 3, 4, 5, 6 units across. But a multiplier of 3. The scale factor is 3. Just like that. Scale factor is positive 3. Positive because the pointing in the same direction. And 3 because the thing, one dimension between 3 times what is originally. The scale factor is 3. The next thing we need to find is the center of the enlargement. And you find the center of the enlargement by drawing the corresponding point until you find the point of intersection of lines join the corresponding point. It's simple as that. So this point and this point correspond together to each other, for example. So the center of enlargement is somewhere on this line. And this point and this point correspond as well. So if you use the ruler and draw a straight line through them again, use the ruler and draw a straight line, project it back. It's telling me that the center of the enlargement is right here. Now I can check that to see if it is correct. But the scale factor also affects the distance from the center of the enlargement. So the points will also undergo a scale factor of 3 in terms of distance from the center. So for example, the distance from here to here is 3 units. So the point is the center and the scale factor is 3. The image of this point is going to be 9 units, 3 times 3 from here. So you can check it. Is there 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units. That's confirmed. This is and that is the another point. But if you work for 1 point, you're good to go. That's why I do a little for 1 picture. Remember, the scale factor affects the size of the object itself. It also affects the distance of the image from the center. Scale factor also works as distance from the center. So, if the scale factor is 3, the points from the center are tripled to get the image. All right? So that tells me that I can confidently say that this is the center of my reality. What are the coordinates of this point? Negative 10, 7. Good. This point is negative 10, 7. Here, guys. When I get this, all of these they need to do is go and do the question over. Video is here to assist you. Read over. And all that will happen with a different question with a different case, we are doing the same thing with a different question and a different case. It's not rocket science. We're doing the same thing, different question with a different shape. We do the same thing that we did in this one. Generally speaking, if you can clear one question, you can do any other one. And this one is just a good question. That's so many questions in each one. That's a good transformation. All right? You get little reflection, you get little rotation, you get some enlargement, and so on. All right? So we're going to describe it now. It's an enlargement of scale factor 3, and the center is the point negative 10, 7. You don't find the center of the enlargement, you're not going to get all the marks. It's 3 marks for it. But you're getting a name for the enlargement, name for giving the scale, a mark for getting the scale factor, and a mark for getting the scale. All right? Enlargement. Scale factor. Three and extend factor. I could have written it another way. It's an enlargement of scale factor positive is about the point negative 10 further. You just want to tell them that the center is negative 10 scale factor. It's even listed. Enlargement, scale factor, 3, center, negative 10 they give it a mark. Those are the important things in the description. If you want to list them, give the name and list the components, fix your game mark. Give it a mark. That's so anxious and eager to give you a mark. Why? Because so many people writing foolish things. So if you just list them, I know I write out a sentence. Just going to give you a mark. You give the name of the transformation and if you give the components of the transformation. You want to write like a sentence? Fine. If you just list them, just going to give you a mark. All right? Next one. Q to R. That's this one to this one. I will say it's a rotation. Let me take this off, right? I'll leave this one on the screen now. From this to this, pay attention to this one, guys. This one special, why special? Like you don't come after. And this one gives complete problem. I'm telling you. You don't need to give a problem. God is what you know, you don't know. All right. So, our know is a rotation. Because this point, for example, down the middle here, there's no point in this way. We like to rotate around. That's what it is. Okay. It's turn up to be facing this way. 90 degrees. Right? That's it. This arrow that was pointing down. No pointing across. It's like this arrow turn up stuff, so that it is no pointing this way. 90 degree horizontal, 90 degree anti-clockwise. The first thing. All right? That's what you want to establish. One was 90, because what was vertical is now horizontal. You can look at the arrow turn and say, what is the anti-clockwise? 90 degrees. So you know the rotation, you know the angle, and you know the direction. But you don't know if it's the center. You can't describe a rotation without giving the center. So the center of this one is clearly not the origin, guys. Obviously not the origin. Not here. All right? Most times it's the origin that gives at the center, but this one is not the center, it's not the origin. So we can't say what the origin is on site. You can construct to find it. You find a perpendicular bisector of lines joining corresponding points. And try to make the work easy for yourself. So you need two lines joining corresponding points. The two corresponding points that I see that are easy, this one and this one. Those two corresponding. So look at it. If I label them A, B, C, D. So this is A prime, B prime, C prime, D prime. Can you see that? We can do that little thing for you. So that also can get done. It around the object this way, around it this way. Good. It means that this point and this point don't correspond. This point and this point correspond. This point and this point correspond. And clearly this point and this point correspond. I need two lines joining corresponding points. And I believe two of them. I'm going to use this one and this one. That's a vertical line. It's easy to get the perpendicular bisector of that. I want to do the mathematics easily. One line that I'm going to use. And then the next one I'm going to use these two. Let me join from there. These two. I need the perpendicular bisector of this line. These are line joining corresponding point. These 2 points correspond. And we can put in the perpendicular bisector for that one from now. So the line that cuts it in half and is perpendicular to it. How long is this line? 1, 2, 3, 4, 5, 6, 7, 8. So the perpendicular bisector is going to pass through 4. 1, 2, 3, 4 right here. And perpendicular to it. See there? This red line is the perpendicular bisector of that blue line. So the center is somewhere on this red line right. And there's another perpendicular bisector. Let's use a different point. Let's use purple. Another one. So what did we say? We said this point and this point correspond. Right? And this point and this point correspond. Those 2 points correspond. This corresponds to this. Right? This one and this one correspond. This one and this one correspond. I'm going to use those 2. What do? I join them. Yeah, draw a straight line. Supposed to draw a straight line, guys, right? A straight line. Then I need to find a halfway mark on this line and draw the perpendicular to it. I want to see where that perpendicular cross this line. Let's look at it now. Let's count it off. So this line, we can break it down into how many vertical and how many horizontal. Look at it. 1, 2, 3, 4, 5, 6 down and 2 to the left. Halfway of this line is going to therefore be 3 down, 1 to the left. 1, 2, 3, 1 to the left. So this is the center, the midpoint of that line. This point right here is the midpoint of that line. If we can measure to the rule line, no problem at all. But this is clearly the halfway mark of this line. You want a perpendicular on that line. You can put your protractor on it and get the perpendicular to it. But watch this now. You can get another way. The gradient of this line is what? What's the gradient of this line? If we want to use gradient, it is rise 3, 1, 2, 3, run 1, don't it? The gradient of this purple line now is actually 3. 3 over 1. The perpendicular to that line is going to be minus a third. Flip it and change the sign. So rise 3, run 1. Yes. This line has a gradient of 3. So you want a line that has a gradient of negative 1 over 3. Rise negative 1, run 3. That's what you want. Rise negative 1, run 3. So watch this now. Or I can say run 3, rise negative 1. Same thing. So starting from here, I can run 3. 1, 2, 3, run negative 1. Come down. See here? The line that I want to pass through here. So if you use a protractor and just put a perpendicular on it, sorry. Put the protractor on this like so. And catch the 90 off it, you're going to get this line just to see it. That's the next perpendicular bisector. So these 2 perpendicular bisectors, they meet right here. That is the center of the line, of the rotation. Sorry. That point is the center of the rotation. Question like this, you're going to do it over, do it again. 2 perpendicular bisectors. That's the center of the rotation. Now you can actually check it. I'm going to take these off now, and we can literally check and see if it is true. I'm saying that this is the center of the rotation. Watch this stuff. So if I draw a line, for example, from here to here, and from here to here, that's at 90 degrees. Yeah? That's at 90 degrees. So this rotate 90 degrees down, sir. 90 degrees clockwise. With another point. Up here, we know this and this correspond. This and this correspond. That again is 90 degrees. You can see it. Huh? So this rotate 90 degrees down this. So you can literally test a couple of the points. You know, correspond to one another. This to this. That's 90 degrees. This rotate to down this. 90 degrees clockwise. So that's the center of the rotation. So we can describe what are the coordinates of this point? -4, 2. The rotation is this way, clockwise. 90 degrees back. Right? 90 degrees. Anti-clockwise. Anti-clockwise. That's what I was saying. Anti-clockwise. That's what I was saying. 90 degrees anti-clockwise. That's why I did this way. 90 degrees, and it did say anti-clockwise, but this was this way. This was this way. It rotate up so to go like that. So it's anti-clockwise 90 degrees. All right. Anti-clockwise 90 degrees. So let's try it. Anti-clockwise 90 degree rotation about the point negative 4, 2. Let me leave back some other times. Leave the money. I can get back to it. All right, so this point is negative 4 to center of the rotation. Anti-clockwise, 90 degrees. But this is an anti-clockwise. Ninety degrees rotation. About point. Let's check if we give everything. Give the name, 3 components. Angle, direction, and center. Name, angle, direction. What about that? This is a nice question. Just say you do about it. The question you do and do. Right? You do it over and do. That finishes that question. Let's go on to number 4. This is a question. I love these questions. They give you coordinate geometry, the graph, the lines. They can read off everything on the graph. You can see the y-axis intercept. You can count out the gradient. You just have less calculation needed when you can see the graph. Like this question. It says lines L and M are shown on the square grid below. Write the coordinates of the x-axis intercept, the x-intercept of L. Which one is L? This one is L. X-intercept is right there. This question is asking us for this point. That is 6, 0. 6, 0 on the x-axis. 6, 0. Don't put 0, 6 on the first. The y-axis intercept of M. That's this one is asking about right here. For the y value. 0, negative 2. Y-axis intercept. 0, negative 2. That point. One is 0, negative 2. Don't give it away. Don't put negative 2, 0 in it. 0, negative 2. Those 1 mark. Very important. Don't give them away. I like them 3 marks. Next question. The equation of line L is this. It says find the value of K. Given that this point is on the line. So if this point is on the line, what it means, you can pick the coordinates of this point into the equation. The equation is still valid. That's what it means. You can fit the values into the equation or work out the equation. You mean that when the x is 9, the y is k, you can fit them into the equation. The point satisfies the equation. If you know the x value is 9, I'm going to put the 9 plus 2 times the y value is k, that's 2 times k, minus 6 equals 0. I've placed the coordinates in the equation. The point is on the line, point satisfies the equation on the line. You can substitute the coordinates of the point into the equation. And it means 2. So solving this for k now. So this is 9 minus 6, that is 3. So we have 2k plus 3 equals 0. Transpose the 3 and divide the 2. You must say that the k equals negative 3 over 2. Negative 3 over 2. Could we also see this on the graph? Could we ever see this on the graph by looking where x equals 9 is on that line L? And see what the y value is. Where x equals 9. So look at the graph and see if it makes sense. Here, out this would have been 9, right? This would have been 9. See there? Y value says negative 1.5. It's negative 3/2. You can trust your calculation. Minus 3/2 the Y value right here. Right here is the point at the top. 9, 2. So the K is negative 3/2. But you can see that. Good. Your calculation and your graph consistent. You can trust that answer. Next question says, find the equation of line M in this form. What do we need to find the equation? The gradient and the y-axis intercept. Let's see what we have on line M. This one is line M. We have the y-axis intercept already. The C is equal to negative 2. What we need is the gradient M. Gradient is rise over run between any 2 points. So for example, we can use any 2 points, like for example, here to here. Rise is 2 and the run is 1. So the gradient is 2 over 1, which is 2. Rise 2, run 1. Simple as that. On the line. 2 points, rise 2, run 1. So the gradient and the y-axis intercept are good to go. Now this question down here, we're going to say the gradient is 2 over 1, which is 2, and the C is negative 2. So the equation is y equals 2x minus 2. And the C is negative 2. That's the equation. How to go to that? Nice and easy. Give it a graph, you don't need to know about calculation. Get everything you want from the graph. All right, next one. Show that the equation, show by calculation that line 1 and line 2 are perpendicular. Perpendicular lines have negative reciprocal gradient. But when they tell you to show that 2 lines perpendicular, you can show that the product of the gradient is negative 1. The product of the gradient is negative 1. They want to show that the gradient of L and the gradient of M is equal to negative 1. That's what they want to show. When lines are perpendicular, the product of the gradient is negative 1. So we have a gradient of line M already. We just said it is negative 2. No, we said it is 2. M. Well, the gradient of line L is equal to what? Let's look at line L. We can count out the gradient from the graph. Line L. Any 2 points. So for example, this point and this point. Look at it. It is rise negative 1. At a negative 1, run 2. So the gradient of line L is minus 1 over 2. Just that I'm leaving these markings on the graph, you know, so CSEC, so get me answer them. These markings that I've placed on here, I'm leaving them. The part of my solution. The gradient of line L is minus 1 over 2. See here, gradient of line L, minus 1 over 2. The line L times gradient of line M is minus a half times 2. That equals negative 1. Therefore, M is perpendicular to L. That's it. But the product of the gradient is negative 1. Huh? What's different? Yeah. No, you have to show them, you have to tell them some relationship between perpendicular lines. You have to state what the relationship is between perpendicular lines. So if you, based on what you would say, you would have to be able to tell them that since the gradient of L is a negative reciprocal of the gradient of M, they are perpendicular. The easier way to do it to show that 2 lines perpendicular is to show that the product of the gradient is negative 1. So going forward, that's what you do. Good. Now, if you have one gradient and you want to find the other one, you flip the one that you have and change the sign and do the negative reciprocal. But anytime a question tells you to show that 2 lines perpendicular, to show that the product of the gradient is negative 1. And then to show that 2 lines parallel, then the 2 gradients are equal. Get me? It's easier to express that way. To show that the product of the gradient is negative 1. Get me? Right? It's kind of easier than to say one is the negative reciprocal of the next. Easier to show that the product equal negative 1. All right, good. Next one says L and M represent the graph of a pair of simultaneous equations. Using the graph, write down the solution for the pair of equations. So the solution for the pair of equations would be the point of intersection. The point where the two lines intersect each other on the graph. Because when you solve simultaneous equations, that's what you're doing, you know. You're finding the point of intersection. It's the point where the coordinates satisfy both equations. That's what you want. So you're looking for the point of intersection, the two lines. Which is right here. That point is 2, 2. See that? So the answer for this one down here is 2, 2. Simple as that. This point is 2. If you solve the two equations simultaneously, this is where you're gonna get. Easy one, man. The CSEC like to give you, when they give you these objects, sometimes they give you a curve and a line, to ask you something about where the curve and the line intersect. Right? And that is it. All right, just checking something. The other class, somebody told me that I might go to clear. Alfred, you can hear me clearly? Julian Jackson, somebody.
Yes, sir.
Yes, sir. All right, good. All right, good. When I hear me clearly, let me know, yeah? This might somebody tell me like it's going on. I need to let them go on. All right, let's continue. Statistics. Cumulative frequency curve. All right, first I said cumulative frequency curve below shows information about the time taken by 200 students to solve a math Olympiad problem. All right, so these are the 200 students up here. They only represent the time. Remember, the ones who took the shortest time to complete the thing are the ones down here. The ones who took the longer time to do it are the ones at the top. All right, so the way of lining up the students in ascending order from the ones who took the shortest time to the ones who took the longest time at the top. All right, because see here, these down here correspond to the times down here. And these at the top corresponds to the time up here. Remember, this graph, it shows either less than or equal to time taken or less than time taken. But usually, the frequency graph is done from group data. You don't know the actual time taken by the students. What you can know is how many students took less than or equal to the upper limit time, or how many students took less than the upper boundary time for each group. Right? I'm just repeating those things so you can go back and listen to the video and so on. All right. It says, using the cumulative frequency curve, find an estimate for the number of students who took more, see, more than 50 minutes. You see this statement here, so tell me that we have a less than or equal to graph right away. But it's more than 50 minutes means greater than 50. Greater than 50 minutes. So it means that the graph is going to show you how many took less than or equal to 50, and the rest of them took more. Remember, the graph either shows you how many took less than or less than or equal to. So since this question is asked for how many took more, which means greater than, the graph is going to tell me how many took less than or equal to. The rest of them took more. So all you have to do is find 50 on the x-axis here, so when you read it up on the graph, it is telling you how many took less than or equal to the 50. The rest of them took more. So I'm going to mark that this is a less than or equal to graph right away. This is a less than or equal to time graph. That's what it's telling me. How many took less than or equal to 50, and then the rest took more. So come out here and say you find 50, so the 50 mark here, so lead it up on the graph, and you're going to see how many students took less than or equal to 50. The rest of them took more. If you come right up to here, right up to there, reach across, right across to here. All right, pause a little bit. Something we should have done before we start. When you give me a graph, just always establish the scale of the graph before you start to read anything from the graph. You want to find out what the scale of the graph, you want to find out what each mark on the graph represents. Right? For example, right here, each analytical line is 1 on this horizontal axis, 1 minute. Consider that 10 intervals to 10. So each analytical line is 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Vertically now, there are only 5 intervals. 1, 2, 3, 4, 5 to 20. So it's 20 divided by 5 intervals. Each interval is 4 students. That means that each of these decal mark represents 4 students. 4 students. You can put it from down there, so 4. You don't forget. Each of these decal mark represents 4 students. Get me? Let's go up here, son. So we want to know what this represents. This is clearly 4 from the top. If the top is 200, if the interval is 4, then it's right just on 96. So that means that 96 students took less than or equal to 50. They don't have to how many took more. So 4 take more. 196, my mistake. 196. Yeah, 196. 196. So it means that 4 took more. But after that, 4 up here took more than the 50 minutes. Is there? I start talking about out here, sir. Which represent this part of the graph over the top, which is just in this gap inside us. This 4. So it's actually 200 minus the 196. Can you look at it back here? 200 minus the 196. 196 took less than or equal to 50 minutes. 200 is the total, so it's 200 minus 196. 200 minus 196 is 4 students. It says the median time taken to solve the problem. So the time that half of the students took less than or equal. 200 students, they want to find the time that 100 students. They come on the graph, I find 100. Half of 200 is 100. So right here, this 100 right here represents the position of Q2. Q2 is the median. You have to read it across on the graph over here. You will find it good and so again. It's like right between these two marks here. Right in between this. That's 30. Third one, 32, 33 and a half. This is Q2. It's 33.5 minutes. Is the median time. 33.5 minutes. Just like that. 33.5 minutes. That's it. Put 34, put 33, then we are not feeling. What the graph give you. What the graph give you, don't need to adjust anything. Whatever the 100 give you. 33.5 minutes the graph is giving you based on that. But I'll be able to zoom in on this device and see that it's actually right inside here, right in between these two lines. So that's where you meet the graph. That's where 100 meet the graph right in between. Right here. Right in between. See that? Good? In between 32 and 34. 32 and a half. Next question. The probability that a student chose at random took at most 28 minutes. The 28 minutes is the most. This means less than or equal to 28. Can't pass 28 minutes. So we'll find out how many students took less than or equal to 28 minutes. Divide that by the 200 students to get the probability. But that's not. We'll find out how many students took less than or equal to 28 minutes, which is what the graph will show you. You see to find 28 on the graph, read it up and see how many students that shows you. Because the graph is showing you how many students took less than 9 at any time. All right? So 28 minutes to see how many students took that. Less than 9 to that. Let's mark it right here. Right here says 28 minutes. So remember the graph is showing how many people took less than 9 at any time. You come on the graph here on this line. Lead it up to the graph. I'm gonna say, like it's past here saying, all right, I'm gonna put the right in intersection. Let's say it's right in intersection. Come across right here. Let's see what we see. That is 64. You know? Remember, each of these is 4, that's 64. So 64 to 200, the probability. So 64 students took less than 28 minutes, less than 28 minutes. Probability of getting one of those 64 students is 64 out of 200. All right, so that is it. So this answer becomes 64 out of 200. The probability, yeah, simplify. That must always simplify. 64 out of 200. It must always simplify. That becomes what? 32 over 100. When simplify it, lowest terms is what? 8 over 25. Thanks. That's it. That is the lowest term. 8 over 25. All right. Next one. Using the cumulative frequency curve, complete this table below. So this is the question now that is testing your ability to find out what the frequency values are from cumulative frequency curve. Frequency values now are the difference in the intervals. So look here. Remember, I know, to draw the cumulative frequency curve, they are using these upper limit values. Always upper limit values because they're less than or equal to graph. And the value before this would have been 0. So between 0 and 10 is 12. That's why less than or equal to 10, you have 12 people. You can see it on the graph that 10 corresponds to 12. Let's look at it. Here, 10 corresponds to 12 right here. You can see. So between 0 and 10 interval is 12 students. That's why the frequency for the first group between 0 and 10 is 12. Then between 10 and 20, the second group. Let me show you with this one. This is the value up here, read across here. Let's see what this is. That is 20, 24, 28, 32. And this is half of 4. That's 34. So this is 34. So this interval is how much? 22. So the second frequency is going to be 22. Let's look at it. If that is correct. 22. This is 22. We'll continue and check the rest of them just to make sure. The next interval is between 20 and 30. That's 42 students. Between 20 and 30 is 42 is the frequency. Let's check it. 42. Between 20 and 30, I'm just going to do it this time for you and show you. So between 20 and 30 is 30 here. Let's see what 30 corresponds to. 30. We'll bring all of them for you, even though I don't need to. Let's just show you how you read information from a cumulative frequency graph. So between 20 and 30 group, that group, okay, up to 30 or so. How many students in that group? Up to here, read across as cumulative frequency here. That's 4 less than 7 than 80, that's 76. So 76 minus 34, how much is that? 42. See that? Inside there, we have 42 students in that group. 76 minus 34, that's 42 students. So the frequency in that group is 42. Now look at this 42 down there. See there, 42. Let's do the next one just to prove it here. The next group is between 30 and 40. That's less than, sorry, that's less than or equal to 40. Right here. I'll take the difference. Let's look at it. This is saying it is 84 students in that group, in that interval. So let's go to 40 and see what 40 gives us. 40 here. What I'm doing now, I don't need to do it for the question, but I'm just showing you how you can read frequency values from a frequency curve. See how many students are in the interval. This one going up by 10. And they're using the upper limit value because it is less than or equal to 1. The 40 here. Open the graph, 40. And see how many students get less than or equal to 40. Right in this line, takes us right out to 160. Flat. 160. So this interval here, so 160 minus 76. How much is that? That's 84. That's why the frequency in that group is 84. Number of students in that group is 84. We can actually fill in this figure now, you know. I know that total down here is 200. You know the total down here is 200. You can literally add up these, subtract from 200 to get this one. You can do that now. So do that for me and so again. I'm going to check it on the graph if it is correct. So 200 minus each of these for me. Add up these and subtract. And see what this figure is. And I'm going to check if it is correct on the graph. What this group is. Check it for me. 200 minus some of those. There you go. And again. Huh? 36. So less than 50, between 40 and 50 is supposed to be 36 students. Less than 50. Supposed to be 36 students between 40 and 50. Let's see. So but we have 50 already. We did 50 already. Remember we did 50 earlier? 50 corresponded to 90, 196. We did correct. Between 196 and 160, that's 36 students. That group is 36. In the last group at the top of here says 4. 50 and 60 is 4. So those are our frequency values, those intervals. See them there? The last group only says 4. So they are 20. So those are our frequency values. Go back and practice on the graph. Watch what the video and do it yourself. What I just did. And oftentimes nowadays, you're setting cumulative frequency graph question, and you have to either read the cumulative frequency values from the graph or the frequency values from the graph. Frequency values are just the values in the interval. Goal. All right? We're completing this now. This is a sum column, guys. For the frequency times midpoint value. So multiply these two. Work out for me now. 5.5. Oh, that one worked out already. Working out 15.5 times 22. What are you getting for yourself? What do you get? You multiply them. 15.5 times 22. So nobody got this one? How much? 341. 341. What I'm asking, nobody got the 22 for there? Got it? All right. So if you never get it, the question is to do over the question and get it yourself. So when you see what is done, you go and put in some work, do over the question, watch the video, do it yourself and see it for yourself. You can't just sit down and leave it, otherwise you're still gonna be at square one. You're gonna get the same question again and can't do. I put in the work when you go home, ladies and gentlemen. Go home and do it for yourself. The video is there to help you. Pause and play the video and do it yourself. What I just did a while ago. And you see that there's nothing to it. And then this one now is 45.5 times 36. What we get for this one? 1068. That's it, flat. 1638. And then everything add up too much now. That's the sum of the sum. It's add up too much. What does it add up to? What are these add up to? You need the sum of the sum to get the mean. Add up all of these now. This plus, this plus, this plus, this plus, that plus that. What again? Yes, I remember the question. Give me digit. Huh? 6, 3, 2, 0. That's it. So the mean is this divided by that. Simple. Information to calculate an estimate of the average time. The average time is the mean, you know. That's the sum of the sum divided by the number of students. 6,320 divided by 200. What are we recording? How much? 31.6 minutes. That's the same minute. I have to put in the word minute there. I have to answer for the average time. Time is in minutes in this question. And the data is in minutes right here. That is it. Question done. Next question, number 6. Another nice question right here. This question says diagram below. Let's take pi 12/7 and we'll do some circular measure. Diagram below shows a scale drawing of a running track. Consists of a rectangle and 2 semicircles with diameters LN. The diameter across here so is LN. So let's work out the radius from now. The radius is 49/2. I would tend to work in radius, right? 49/2 radius. Which is what? 24.5? 24.5. Right? Of these semicircles. And the 2 half circles make a whole circle, don't you? 2 half circles make a whole circle, right? When they say that this length is 98, over here said 98 as well, because they say it's a rectangle. They say it's a rectangle. Rectangle. The 2 sides are 98 across here. Right? 98 and 98. And then this and this together make a circle. A whole circle. So the total length is 350. So the total length is 350. So you calculate the total length and you can about 350. The total length is equal to the distance around it, right? So the 2 long sides, which is 2 times 98, plus the 2 half circles make a whole circle. The circumference of a circle is 2 pi r. 2 pi r. There's 2 times 98 plus 2 times 2/7 and 24.5. That's supposed to give you. Let's see what it is like that. But that's why I put 2 pi r over here. And it becomes a whole circle. The 2 halves become a whole circle, right? Right? From 2 pi r. The circumference of a circle. 2 half circles make a whole circle. Right? 2 times 98 and 2 long sides. 2 times fraction 24/7 and 24.5. 350. Right? No, that is it. Therefore, school. All right. This one says, Nathan walks at a constant rate of 1.4 meters per second. All this means is that he does 1.4 meters in 1 second. That's all it means. It's not complicated. Check at the time it would take him to walk 7 laps. 7 laps is 7 times 250, don't you? Don't you? It's like a speed time distance question. I want to find the time. You can treat it like a speed time distance question. So you can say speed equal distance over time. I'm trying to find a time, right? The time equal distance over speed. That's how we calculate it now. The time that he walks is going to be the distance. He walks 7 laps. Each lap is 350 meters. So the distance is 7 times 350 meters. Divided by the speed of 1.4. Speed is 1.4. When you get this answer, it's going to be in seconds. By the time is in seconds, it's meters per second. So the distance here is in meters, the speed is in meters per second, so the time is in seconds. The result is going to be in seconds. What is work out to? Come on. Don't give me digits. 1750 seconds. Simple. We're going to simplify it and put speed equal distance over time. The time equal distance over speed. You walk 7 laps. Each lap is 350 meters. The total distance in walking is 7 times 350 meters. Divided by the speed of 1.4. Next question. It says, Safari runs 1 lap in 68 seconds. He's running now. The person is running. He runs 1 lap in 68 seconds. Determine the number of laps Safari can complete in 1 hour. Running at the same speed. Basically then, this time divided by this time. Because every lap is 68 seconds, and they want to run for 1 hour. So to find the number of laps he's going to do, we're going to divide it 1 hour by the time that he takes for 1 lap. The balance on that, see that? The number of laps. Going to be 1 hour of running divided by 68 seconds of running. I'm going to convert the 1 hour into seconds and divide it. You get me? Divide 1 hour into seconds. So I want to know how many 68 seconds is in 1 hour. That's what it is really. Each lap is 68 seconds. You want to know how many 68 seconds is in 1 hour. You want to convert the 1 hour to seconds. So the 1 hour is 60 minutes per 1 hour is 60 minutes, and each minute is 60 seconds. Don't you? Divide that by 68. What that work out? This is seconds now. This is second. Divide in the unit. It's second. It becomes second over second. What did I get? How much? Well, what I know? So determine the number of laps you can complete. You can only complete 5. Answer the question. Then we run 5.2 something. 52, right? 52 point something again. So you complete 52 laps. You understand? Then we get 52 point something, you say you complete 52 laps. And you complete a 56 laps, right? Then we put this over here. No, the only lap is complete. So the figure I work out to a 52 point too much? 52 points. We'll try with the next one. So complete 52 laps. Let me tell you something. So that's just an half of the number of something. And say the whole number. Right? That's just an half of the number of something. Number of something is a counting number. So the answer for the number of something is going to be a natural number, counting number. All right? So look what happens. The number of laps is 52 laps we complete. We actually run 52.9 in actuality. So the 0.9 is not a whole lap, yes? Huh? That's it. You get the 52.9 convert this. No matter if you convert this into minutes and convert this into minutes. No, you might put this and put minutes to good. Yeah. If you divide that by 60 and put minutes, good. If you divide it by 60 and put hours, good. Once you put the unit, you go. When you work it out in a second, you say second. If you work in a minute, you say minute. If you work it out in an hour, you say hour. But the question never say, why you must give it in there and say what time? See? Time. Time can be expressed in seconds, can be expressed in minutes, can be expressed in hours. If you want to express it in a just all right, good. But all right, so far. All right, next one now. It says Nathan completes running one lap every 72 seconds. So it might go slower, right? So one person going at 68, this person going at 72. So Safari going faster, don't it? So Safari will complete more laps, don't it? So Safari and Nathan start running at the same time, but Safari will go faster because he's doing he's completing a lap in less time, right? So we'll go faster, but take 58 seconds. So he'll complete one lap. Nathan still a 4 seconds behind him, don't it? Good? So there's a 4 second difference between them on each lap. Okay? Right. So two of them start running at the same time from a point L on the track. Each completed a number of laps on the track. Calculate the least number of laps that each will complete before they are both at L again. So they are both at L again when Safari lap him and catch him up the lap. So this question can work out multiple ways. But what you know is that there's a 4 seconds difference between them, right? So one is going to be 4 seconds ahead, one is going to be 4 seconds behind. You can work out from either way, from either side. So, all right, so look at this number. Let's call Nathan's lap L, N. And let's call Tafara's lap. Right? Watch this now. When the 4 seconds times the number of Nathan's lap equal the lap time for Tafara, that is when they meet again. Because the 4 is the difference between them. And when the 4 seconds between them times Tafara's lap equal Nathan's time, when they will meet again. That's the calculation. So remember, every lap, there are a 4 seconds difference. So when them catch up again, is when the 4 seconds times the number of laps done by Nathan become equal to the total time that Tafari takes to complete a lap. That's when they will meet again. Because there's a 4 seconds between them on each lap. And I understand that calculation the reason there. There's a 4 seconds between them on each lap. So they will meet again when each of the 4 seconds on Nathan's lap add up to the total time that Safari takes to complete a lap. So you want to know when they meet again. Because Nathan is falling 4 seconds behind on each lap. Every lap will fall another 4 seconds behind. I'm going 4 seconds slower every lap. But Tafari is going 4 seconds faster every lap. So they will meet again when the number of times Nathan do the 4 seconds less add up to a total 1 lap for Tafari and vice versa. So that's how you can calculate the time. I'm going to do it another way and show you. So this will work it out for us. So this is just divide this by 4. 68 divided by 4 is the much. 70. And 72 divided by 4 is the much. 18. That means that Tafari going to do 18 laps. Nathan going to do 17 laps. Simple as that. You understand that? Let's use another. More mathematics like that. And see if we can read it out another. You understand that we are not another way and complicated to follow. You know? So 68 and 72, there's a 4 seconds between them. So just imagine that every lap this morning part. So the first lap is 4 seconds behind. Second lap is 8 seconds behind. Next lap is 12 seconds behind. Next lap is 15 seconds behind. So the number 4 seconds. They will meet again when the sum of those 4 seconds becomes equal to 68. You understand me? Because it means now that 68 seconds is now a full lap behind the other person. You get me? If you look at the other way, the man who's going faster, he's going faster by 4 seconds. The first lap is 4 seconds ahead. Second lap is 8 seconds ahead. The next lap is 12 seconds ahead. The next lap is 16 seconds ahead. So you want to know how many laps is going to be 72 seconds ahead. Because at 72 seconds ahead, he's going to now meet up with the other person. When that person is at the same time completing a lap. Because he does a lap in 72 seconds. That's why I say 4 times Nathan lap. For each lap, you're doing 4 seconds. You want to know when each of these 4 seconds add up to the lap time where Safari I do. Simple as that. And that figure is 17 laps. 17 times 4 equals 68. So 17 times is going to be 68. It's going to be 68 seconds behind the next one. So they're going to meet at the same point. Don't want to do it another way and confuse me, you know. Want to do another way? Now, all right with this thing? For sure. All right, I'll leave this one. Just because the time difference between them is 4 seconds. All right, so if you're not all right with this way, I'll leave it like that. You want to know how many laps, how many 4 seconds you need to add up to the 68, which is the total lap time for Tafar. I want to know how many 4 seconds you need to add up to 72, which is the lap time for Nathan. Yeah, so 2 times, they're both running for the same time. Just that one will run 1 lap more than it. Because Safari is going fast. So then I'm lapping. He's going faster each lap by 4 seconds. So you want to know how many 4 seconds add up to the total time that the other guy takes to run a full lap. So that the two of them end up at the same point again in the race. You get me? Sometimes some simple things are hard to explain. You know? So I'm kind of tempted to do it another way. But if I'm good with this, I'll leave. All right? Let's go. I have another video with this from 3 different ways. You know. Here, here. So I'll play that video as well. You know. Let's continue. This is the pattern question. They get some looking 7 looking thing, like a 7. You know, it's like a 7 shape and a 7 shape and a 7 shape, right? It says the grid below shows the first 3 figures in a sequence. Each figure is made using a set of small squares, unit length, that are both colored and shaded. All right, so you have shaded and white, unshaded. It says in the space below, draw the 4th shape. All right. Let's look at it. So we have 3 on the top, 4 on the top, 5 on the top, don't you? So we need 6 on the top now, don't you? That's all? All right, so now put 6 on the top. So we can get 6 on the top. 1, 3, 4, 5, 6. Then no, the diagonal, notice the diagonal come down until it's underneath the first one. You see that? But can see that? It come down the diagonal until you're underneath the first one. It come down the diagonal until you're underneath the first one. So we need to come down this diagonal until we're underneath this first one, right? So we're on this diagonal. Bam, bam, bam. Something is wrong. This is where it's higher. But it's too low. Fortunately, I know this is wrong. That is it. Let's check the diagonal. So we have 1, 2, 3, 4, 5. We'll start 16. 1, 2, 3, 4, 5, 6. Good. That is my shape, guys. That's my shape. I need to be shading out all of this, but I'm just going to leave it like this. Trust me, 6 you will actually. Not possible. Give them this. The shade is bright. That's what I give it to them. When you have the time going and always time I shade this. So 1 mark, 2 marks. Trust me, give it 2 marks to give them that. That's the shape, figure 4. Right? You have to kill yourself and shade out the whole box and all. That is good. Trust me. All right, next question says the number of colored shapes, colored squares C, total number of squares T, so they don't have anything for the white ones, right? And the perimeter of P, and the perimeter of the figure P follow a pattern. So do the pattern and answer the question that follow. So let's look if there's a pattern in the formula. And this one going up by 2, plus 2, plus 2. So 2n is a part of the formula in this column. 2n. The first figure is 5. It becomes 2n. 2 times 1 is 2. If I add 3 to make 5 in the first sheet. This one going up by what? By 4. Plus 4. Plus 4. So 4n is a part of this formula here. 4n. 4n. This one has 4n in it. The first figure, 4 times 1 is 4. We have to add 8 to make the 12 in the first figure. So add 8. That's a formula for the second column. This one no. So this one is a figure number. There, figure number plus 2 squared. Easy. This one easy. Figure number plus 2 squared. N plus 2 squared. N plus 2 squared. That is it. That's what this means. All right. Now that we have those, we can fill this out now. We take the 11 and drop it on this. 2 times 11 is 22. 22 plus 3 is 25, right? 25. This says it's 52. Let's check it. 4 times 11 is 44. 44 and 8 is 52 over 3. So that is 52. Sorry. And then this one now becomes 11 plus 2. This one becomes 11 plus 2 squared. That's 13 squared is 100. That's that one. This one now. This is 49. You want to know the n? Put this equal to 49 and find the n. So right here, we're going to put 2n plus 3 equals to 49 in this row. Subtract the 3 here, so we get 2n equals 46. Divided by the 2, we get n equals 23. So this is 23. How could you know it's 23? See 23 right here, so that's the n. So could I know that thing? That is 23. All right? So we did too much there a while ago. Then now we take the 23 now and drop it on this formula. 4 times 23 plus 8 is about 4 times 23 plus 3. 100. Huh? 100. 4 times 23 plus 8. 100. All right. I believe it. Table done. Sweet. How many white shapes on figure 11? Figure 11 here, so. Figure 11. The white shape, remember, this is the total shape, you know. And that's the number of colored shapes. Those are the difference. See that? There's 169 minus 25. That's all? 169 total minus 25 colored equal 144 white, don't it? That's all? What's the difference? 1 mark for that. Whoa, what a question done quick. I like it. Quick and fast. Classroom must look empty today as well. Oh boy. The classroom I get full and more full these days. Empty. Class as you know, first thing in come with the math exam and then that's what. No, we talk about that. You know, now cooperate. Not cooperate. You unlike. We have two people unlike. We have two people unlike. Nobody want excellent results. We're not taking full advantage of what is available. It's unlike. It's have two people unlike. Yeah, I understand. Yeah, I understand. Okay, how many people online? 1, 2, 3, 4, 5, 6. Anyway, next question. Number 8. Functions. F of x is this, g of x is that, h of x is that. You want g of x minus 2, all you have to do is take x minus 2 and substitute in the x function right there. All you have to do. So the g of x minus 2 becomes equal to x minus 2 squared. You put the x minus 2 where the x is right there and square it, and then subtract the 5. Then to simplify it, we're going to expand this out and then subtract the 5. Expand this, you get the first term squared is x squared. Quad product over 2 is negative 4x. Second term squared is plus 4. Then subtract back this 5 out here. It becomes x squared minus 4x. Then this 4 minus 5 is negative 1. That is it. This one was f of minus 11. F to minus 1 of 11, sorry. We can do this 2 ways. We can find f to minus 1 of x first, and then plug the 11 in it. Or we can make this expression equal n and solve for n. I kind of like doing that way. I don't have to find f to the minus 1. Let's do it that way. We're going to put this equal some number, right? I still have to do the inverse. If f to the minus 1 of 11 equals n, then 11 equals f of n. When you find n, you find the answer. What is f of n? F of n is when you put n in this function. You put n in right here. So it means that 11 is equal to 4n minus 1. I will take the n and put it in here. And I will solve this for n. When you find n, you have your answer. So if you over the 1 first, this is going to give us that 12 equals 4n. Divide by the 4, you're going to get n equals 3. Therefore, f to the minus 1 of 11 equal to n, which is 3. That is a nice way to do it. But you have to do it in there. What then? If you find f to the minus 1 of x first and then plug in the 11 and get 3, same thing. No problem. All right? Next question. The value of h of 8 of 1. What is h of x? That's 3 to the x, right? 3 to the x. Let's write it down here. H of x. 3 to the x. What is h of 8 of 1? We're going to do this h of 1 here first. So it becomes equal to h of 1 now means that they put 1 in there. They get 3 to 1. That's right, perfect. H of 1 is equal to 3 to the 1. First class. So this h of 1 is inside here. So this now becomes h of 3. H of 3 means they put 3 inside here now. That now becomes 3 cubed. I put the 3 up here. 3 cubed. 3 cubed is 27. Remember, for this h of 1, they could have written instead h squared of 1. Right? They could have given you this. Yeah, man. 8 squared of 1. 8 of 1 is same as 8 squared of 1. It's the same thing. That though. Next question. Quadratics. So the function f is defined as that as a quadratic, it's a small shape quadratic. Remember, it has an axis of symmetry. And sometimes you can see the symmetry in your values in the table. And look for it and pick up your symmetry in the values in the table. All right. So these values, these x values are going on the same constant interval of 1. It means that these y values are going to be symmetrical. These y values are going to be symmetrical about a line of symmetry. So this 0 corresponds to this 0. So going on from this 0 reach 4, so going on from this 0 must reach 4. Going in from this 0, same as coming in from this, so this is negative 2. We can literally use the symmetry of the values to know the answer. So those are the values, you know. It's one easy. I was using the symmetry of the values. If you want to work it out, you could, for example, take the negative 2 and plug it inside here, so, and get this 4. And if you take this 0 and plug it here and here, you see that the answer is negative 2 there. You can know that it is correct. All right? Let's look for the line of symmetry now. You can see from the table. So these values come in towards negative 2, and these values come in towards negative 2. Means that the symmetry is right in this area. The values are symmetrical about that red line. The values are symmetrical about that red line right here. Which represents the line of symmetry. The x value is the average of these two, right halfway between the 0 and the 1. That's the x value of the line of symmetry. Halfway between 0 and 1 is half. So the x value at the turning point at the axis of symmetry is 0.5 or half. Let me put 0.5. And then to find the y value, you can put 0.5 into this. To find the y value at the symmetry value, the y value, the y value, y value at the turning point. You put the 0.5 in this. It will be 0.5 squared minus 0.5 minus 2. Minus 0.5 minus 2. What are we opposed to? That's minus 2.5 plus quarter. That's minus 2 and a quarter. Minus 2 and a quarter. That's what I do. Let me say the turning point is half minus 2 and a quarter. Just like that. Using the symmetric nature of the quadratic function to make the work easier. So the turning point, the vertex point has these coordinates. Minus a half, 2 and a quarter. Not given, but you have to know that it exists. That's where the turning point is. Minimum turning point at the vertex. Never mind, this can be the minimum value. And the minimum value can only appear at 1 point. You have the minimum value at 2 different points. Minimum value is at a vertex point, 1 point only. The negative 2 can be a vertex point. All right? Has to be the 2. That is it. And I want to sketch a graph here, all right? You complete the table and plot the graph. We're going to plot the graph. They give us the axis already. So let's label it up. So 1, 2, 3, 4. So it goes to 3. So we're going to go 2 to 4. Let's go 2 to 4. We're going to go 1, 2, 3. Minus 1, minus 2. Yes, I'm scale. And the y-axis is going up to 4. And down to negative 2. Negative 2 and a quarter. So we can go 1, 2, 3, 4. Minus 1, minus 1. All right. So 1, 2, 3, minus 1, minus 2, minus 1, minus 2. Let me see. 1, 2, 3, 4. put in the axis of symmetry. Axis of symmetry was a hard, right? Hard. The value of symmetry is about this line. Point to the first. So the first point is negative 2, 4. Up here. Negative 2, 4 is up here. That's up here. Negative 1, 0. That's on the x-axis. Negative 1, 0 is right here on the x-axis. 0, negative 2 is on the y-axis. That's right here. Negative 2, 0 is right here. Then 1, negative 2 is right here. Then 2, 0 is on the x-axis again right here. Then 2, 4 is up here. Then the vertex one, negative half, negative 2 and a quarter is on this red line, a vertex line, axis of symmetry line. So we need 2 and a quarter. Let's map it up. This is 2 and a half. Negative 2, negative 2 and a half, negative 2 and a half. The negative 2 and a quarter is right here, after the field. We're talking about this point, right here, the vertex point, right here, the minimum point. That's the vertex point. 0.5, negative 2 and a quarter, or negative 2.25. That is the vertex point. You draw the smooth curve through those purple points, and it must come down to here. All right, so you know that they give you this point, you must know how to find that point. And know that the graph has an axis of symmetry. We're going to draw a smooth curve now with those points. That's it. Don't want no more than this. Yes. You have to know the what of the function of the vertex. You can't come across yourself. What if you have no like that? You have to come down to the minimum point. You have to find the minimum point and come down to it. Some table give you the minimum point of that part. A lot of them, you have to know that you can find it. Go back over the question and find the axis of symmetry. Find the axis. Find the vertex. So what you can get from this field, you can get x, y, t from this. Go and find the terminal. Alright? You have to know the pattern of the vertex. Alright? Minimum value is the lowest y value. Lowest y value. This is 2 and a quarter. Lowest y value of the graph coming in. Remember, you know, if you think of it this way, the function is giving you y value. You put in x values in the function and it gives you y value. The lowest y value that this function can give you is this one down here. Because for other x values, this graph is going all the way up to infinity and going all the way up to infinity. For any other x value. The lowest y value that this graph can, this function can give you. The lowest output y value that this function can give you. This is negative a quarter, right under this minimum point. That's why that's the minimum value of the function. The lowest value that the function can give you. Negative 2.35. You get me? Remember, your function value is a y value. You put in x values, the domain values, and the function gives you those y values. All right? Oh, question done. Let's draw the graph. So that's it. Number 9. Number 9 says WX and U are points on the circumference of the circle. TV is a tangent to the circle at U. UW is a diameter. And WXU is isosceles. So that's an isosceles term. These two sides each side. That means that the angle opposite this side here and angle opposite this side here. These two angles are each side. Those two angles are each side. All right. This is the diameter. Diameter subtends 90 degrees. So this angle is 90 degrees right here. So we're talking about 90 degrees. All right? So that's something we can know before we start. It says, using appropriate theorem, state three reasons that explain why angle Z, that's this angle here, is 45 degrees. All right. Come on, three different reasons why that is 45 degrees. But to me, to show that this angle is 45 degrees, we need to establish some of the angles inside here first. Okay, reference them. What I will do for this question is put in these angles that make my explanation down here easier. The first I'm going to put that this angle is 90 degrees and put Y on the paper. This angle is 90 degrees, Y. Angle subtended by that, don't it? Subtended by that. But this angle up here, I'm going to tell him that this angle is 45 degrees. You understand this angle is 45 degrees? This angle is 45 degrees, don't it? This angle is 45 degrees. Now, total angle in the axis is 180, right? It becomes equal to 180 degrees minus 90 over here divided by 2, 45 degrees. Total angle in the axis is triangle, right? Total angle in the isosceles. I'm also going to need this angle right here. That angle is 90 between angle between tangent and radius. So that angle is 90 degrees. That's the angle between tangent and radius. Once I have those angles now, I can use them to reference me to the Z, right? The key reason why it is that. You can say, okay, this angle equal this angle up here because angle between tangent and radius. Tangent and chord, sorry, equal angle subtended by the chord, don't it? All right, so see here, we use that blue. So this angle Z is between this tangent and this chord. Chord subtends same angle as circumference. Okay, tangent and chord will be the first one, right? I'm going to a straight line, yes. Okay, it's total angle on a straight line here, 180. The next one I'm going to use angle between this tangent and this radius is 90. The third is angle. Right? The first one is tangent and chord. I'm going to tell them that angle Z is equal to the angle up here. Name this angle, which is XWU, equal angle XWU, which is 45 degrees. Tell them angle between tangent and chord equal angle subtended by the chord. Angle between tangent and chord equal angle subtended by the chord. I'll turn the segment to. The next reason I'm going to tell them it is 90 is 45 because this angle is 90, right? This angle is 90. So I'm going to say the angle here is 90 degrees. Angle W, U, V is 90. W is 90 degrees. Therefore, Z is 90 minus 45. So the Z is 45. Z will be 45. The Z is tangent and radius, right? Angle between tangent and radius. Don't tell him that 45 right? This is also fine. Right? And then the last is the straight line, right? Angle straight line is 180 degrees. So the angle, let's say the Z, the Z degree, 180 degrees minus the 90 and the 45 in the straight line. This is equal to 45 degrees. Easy for that. Angle on subtract. I will straight line right out there. TUV. The angle 2V, right? TUV. That's it. TUV. Then the tangent and chord rule, tangent and radius rule. Straight line, but still we have to establish these angles first. Right? So I did that up here. Establish those angles first so we can reference them easily. And let's go. Right? I think that is what I express. Because that way you express it. I know that's a sometimes how do you express it? When you do the job express, see these angles first. Part B. Diagram below shows a circle with diameter KF, line EFG, and the tangent to the circle, the line is the tangent to the circle at F. Point F, H, K, and J lie on the circumference of the circle. All right? And I want us to, by showing each step in your work, the appropriate find the value of each of the following angle X. That's right here. Now, angle X is subtended, as you can see, by this chord. Same chord is subtending angle 56 up here. These two angles equal. X equal 56. Same chord. We're going to subtend by the same chord. So, angle X. The X degree, right? Angle the same thing. Angles in the same segment, but segment by the same chord. On that subject by the same arc. That angle is 56. And I want angle Y. That's just one. Let's do up on this. So this angle is 56. We just work out one, right? I can tell you that this angle here is the sum of these three. This angle is the sum of these three. Why is that? That's an exterior angle. This angle is on one of the extension of the triangle. Extension of one side of the triangle. It's an exterior angle. Got a triangle like this. Red. Y angle out here is an exterior angle of a triangle. The exterior angle of a triangle is equal to the sum of two opposite interior angles. This angle is that here. So these this one. Look at the red triangle. This is just an extension of one side. And the zero angle. Zero angle of a triangle. Equal to the opposite interior. That y degree is equal to 56.9. I do not know way that. Another way could I do it, you know? He said this angle and this angle add up to 180. You can find this one. That total angle in this triangle is 180. There's too much work that. It's good to know that this triangle is equal to the sum of the two opposite interiors. So y is equal to 56 plus 19. You see here, y degrees is equal to 56 degrees plus 19 degrees. What is that up to? I got like 55 plus 20. That's 75. Right? Y degrees is 75 degrees. Y exterior angle exterior angle of a triangle equals the sum of two opposite. Yeah. That's it. All right. Let's guess that. Let's try some. You got to all right. Let's say diagram below shows 4 points P, Q, R, and S on level ground. The pillars will be placed to mark the outline of a foundation. It says there's a vertical post RT, right at R, is a vertical post at R. Can't put on a diagram here. There's a vertical post placed at R. And it says from Q, the angle of elevation is the angle of elevation of T, the RT, you know, the T is at the top of the post at R. It's 21 degrees. Let me draw it over here. There's like this section from Q up to the top of the post here. Let me draw it here. So it's like you have like this. This is R, and then you have Q also. And the angle of elevation looking at here is 21 degrees, which is up. And this distance is 153 down here. 153. This is 153 degrees. 153 degrees. All right. That's it. That's it. That's the price of the triangle with the mirror. It says find the height of the post. That is height of this post right there. Height of the post is RT. Height of the post is RT, the RT or RT. When I work on that triangle, let's use tan equal opposite over adjacent. Things like that. We have tan 21 degrees equal opposite TR RT, same thing, over 153. Find the RT is multiplied up here. The RT equals 153 times tan of 21 degrees. You guys understand the diagram, Mr. John? You know what they said? Understand what I've said? The diagram? Yeah? Very good. Good. Right, they put a vertical too, but this is looking at this from above, from in the sky. What I've done, I've drawn an elevation view over here so you can see. Right here is where they put the vertical pole, and then you have the angle of elevation looking up like that. I think it's 21 degrees inside. So we do this calculation and find RT. RT equal at the height of it. 153 times the color of 21. That's 58.7. If you do the meter, anything with the meter. Remember to come to last time, you know, in the classroom, remember to come to class. Huh? Anyway, next question. Given that the length of QS is 135 meters, calculate the perimeter of the foundation. Perimeter of the foundation is the distance around the foundation, right? It's telling us that QS is 135. Let's put on the diagram. That's this piece. 135. So then put on the diagram. It's telling us is 135. 135 meters. The perimeter is going to be the distance around the shape. There's this plus this plus this. The perimeter is the distance around it, you know. So the piece that we don't have is this piece. We need to find this piece. See that? You need to find this piece in order to complete the perimeter. Don't you? The perimeter is the distance around the shape. We have 3 parts already. 1, 2, 3. We need to find this piece. PS. Find P is going to work in this triangle. We're going to use cosine rule. Find P. After find PS, we'll add it to these other 3. We're good to go. After that, PS is missing. The cosine rule for PS. Let's do down here. So cosine rule. What are the dimensions? Let's write on the dimensions. 83, 135. 83, 135. And that was 29 degrees, right? Those are the dimensions. Good. This is the cosine rule. You might start like Pythagoras' theorem. The PS squared is going to be 83 squared plus 135 squared. And subtract a piece. So subtract twice the product of those two. And then cosine the angle between them is 29 degrees. Instead of putting a square here, we can take out the square. So PS and the square root of the here. And the one here take on the PS. Let's plot here. The square root of 83 squared. 83 plus 135 squared and 2 times 83 times 135 times cosine 29. That's 11. No, that's the wrong. No, I'm going to go. If you split with 135 square, 2 times 135 and 2 times 10 4. Therefore, the perimeter equal. I don't know for the side, no 10 4, right? So become 153 over here, plus 83 right here, plus 74, plus 110. That gives you the parameter. What we said. So here, 153 plus 83 plus 24 plus 110. It's still 30. All right? Mr. Jackson online, you good?
Yes, sir.
Oh, you're not sleeping. You're not sleeping, Mr. Jackson.
No, sir.
Good. Last question. You passed 45% already?
Of course.
Good. Long good. Remember, we have 2 more mock exams this week. One Wednesday and one Thursday. 2 Saturday. All right. I think we're going to start our marathon revision session Saturday coming in.
Sir, no mock exam tomorrow?
Huh?
No mock
No,
exam.
tomorrow we're going to the other paper.
Oh, okay.
To go to the other paper. All right. Tomorrow's class is to go to the other paper that I gave on Saturday. That's tomorrow's class. We started the weekend coming. So weekend coming, we'll because holiday start weekend, right? And I've set apart the groups already. And we'll have a meeting and assign this day and start the process. Give you guys samples and so on. So you can start 1 week to finish today. But we want to start with some revision marathon session now, like Saturday evening. So all that would go in the evening. So we'll do the Saturday mock exam just the same. All right? So we can't give up that thing now. We'll do the Saturday mock exam. We can go home and we want to stay. And in the evening now, we do like a 3 or 4 hour session, one topic at a time. You might do just a class on bearing, a class on vector, or a class on not bearing, but trigonometry. We have a class on each topic. Revise one topic. All right? So that's what I want to do. Huh? But I'll announce. I'll finalize and announce. All right? So don't worry about it. All right. So this is a matrices question now. They give us these 2 by 2 matrices, and this is a 3 by 2 matrix. It has 3 rows and 2 columns. So that's 3 by 2 matrix. This one. It says, explain why the matrix product QS is not possible. Remember, it has to be we know being conformable or not. The number of columns in the first one must equal the number of rows in the second one, right? So the Q matrix is at 2 by 2, right? It will be at 2 by 2 times the S is at 3 by 2. What is happening here? That the number of columns here, the number of rows here, they are not equal. That's why it is not possible. As far as it be possible, the number of columns in the first matrix must equal the number of rows in the second matrix. Right now, they're not equal. They are non-conformable. It's not possible because ECS, because number of columns in Q, the first one is Q, is not equal to number of rows in the second one S. We say that they are non-conformable. Non-conformable for multiplication. right? So that's the number of columns in the first one, not equal number of rows in the second. Here now. State the order of the matrix product SR. You know, SR, the S is at 3 by 2 again. So it will be at 3 by 2. Multiply that with R now. R is at 2 by 2. This one is conformable because 2 columns and 2 rows equal. That's conformable. So the resulting matrix is this by this. So that resulting matrix takes the number of rows of the first matrix by the number of columns of the second matrix. So the final result is going to be at 3 by. That's the answer. Resulting matrix is at 3 by. Right? That's it. It says calculate the matrix product QR. What is Q again? Q is 2 minus 1, 4, 3. That's 2 minus 1, 4, 3. All right. And multiplying that by R is 1, 6 minus 5, 4. 1, 6 minus 5, 4. So multiplying those two matrices now. Remember, guys, the multiply matrices, you take the rows of the first one, multiply by the columns of the second one. But I must master this by now. It's going to be equal to a big 2 by 2 matrix. 4 values. 2 by 2 and a 2 by 2 give the back a 2 by 2. Let's go through the process again. So this value here is positioned in the first row and the first column. So to get it to multiply this first row by this first column. I multiply row by column by saying first element in the row by the first element in the column. Plus the second element in the row and the second element in the column. So it's first element times first element, second element times second element. First element times first element, second element times second element. 2 times 1 minus 1 times minus 5. 2 times 1 is 2. Minus 1 times minus 5 is positive 5. Now this value out here is positioned in the first row, second column. So to get it to multiply this first row by this second column, same thing. First element times first element, second element times second element. First element times first element, second element times second element. 2 times 6 minus 1 times 4. 2 times 6 is 12. Minus 1 times 4 is negative 4. Now come to this element here now. It is positioned in the second row and the first column. So multiply this second row by this first column to get it. Same thing again. First element times first element, second element times second element. First element times first element, second element times second element. 4 times 1 and 3 times negative 5. 4 times 1 is 4. 3 times negative 5 is negative 6. The last value out here is positioned in the second row and the second column. So to get it to multiply this second row by the second column. First element times first element, second element times second element. First element times first element, second element times second element. 4 times 6, and 3 times 4. 4 times 6 is 24. 3 times 4 is 12. The final result is this matrix right here. This is 7. 12 minus 4 here is 8. 4 minus 15 here is negative 11. 24 and 12 here is 36. That's the matrix color. I'll go to that. Yeah. Next question. It says, given that this matrix, the determinant is 5. That's what it's saying here. The determinant is 5. This means determinant is 5. Means that this product minus this product is equal to this part. We can set that up. This equation was put as an equation. The expression for them term is the this product 4 times x product, which is 4 minus this product negative 7 times negative 1. That's positive 7. I can see that. Right? I want to put it like this. Bracket negative 7 times negative 1. That's all equal to 5. This becomes that 7. So 4x minus 7 equals 5. This come over here after that give me 12. So I'm getting 4x equals 12. Divide by this 4, x is equal to 3. X is equal to 3. Right? Next question. Next up. This question says, in the diagram below, OPQ is a triangle. OPQ is a triangle. ARB and AOQ are straight lines. That's a straight line. And some ARB, AOQ are straight lines. All right. It says B is the midpoint of PQ. This is the midpoint of this line. So this one divides this line half and half, right? R is the midpoint of AB. R is the midpoint of this whole line here. So then it says OR to RP is 1 to 3. OR to RP is 1 to 3. So this has 1 part on it and this has 3 parts on it. So the total part on the line is 4. Total part on the line is 4. Right? Then it says OP, that's the whole of this vector. It's actually 4A. So it's kind of easy now. So if the whole vector is 4A, look at it now. Use it so. The whole vector is 4A. And it's in the ratio 1 part to 3 part. This is 1A and this is 3A. Can you see that? Good. So it means that you can write the vectors on it. So this vector up here is 3A. This vector is here. 1A minus 2. 1, right? The ratio is 1 to 2. The total vector is 4. The vector OQ is 8B. So right out here says 8B. Let's put it up. So this vector OQ is there. All right, so put the information on it. Question says, let's find PQ. Because we have the portion vector here, the portion vector Q from right here. It's easy to find PQ. Becomes OQ minus O. O times the last minus O times the first. So this is just equal to OQ minus OQ. The OQ is this 8B minus the OP is 4A. Implies a PQ. All right? So the vector down here says PQ. All right? This is the midpoint. Then it says, yeah. Divide, no man, not divide the stuff. You can't divide. Yeah, divide one, you have to divide 2 sides, you know. You have to do the division on 2 sides, you have to divide. PQ equal this. Because there are multiple ways to find it, and I want to make sure if I simplify, I must have 1B expression and 1 expression. That's what I mean. 1B expression and 1 expression. Because there are other ways to do the same thing. I don't do this easy quickly, but there are other ways to find the vector. You get me? Other ways might be the multiple terms in there. So it simplifies 8B minus 4A. So on PR now, PR. PR, but that's easy. So we can see it here. So P to R is just minus 3A. But can I say that? Minus 3A. This is just minus 3A. Why is it minus? By going the opposite direction to P, right? P to R is in the opposite direction to the P, right? It's minus 3A. Next question. On RB. RB. So R P is this vector. So we can go from R to B. We can go R to P and then P to B, don't it? Where the PB right here is half of the PQ, don't it? We know the PQ already, no sir? We're going to use that. We're going to go from R to B, we're going to go R to P, and then P to B. That's what I told you. So R to B is R to P, and then P to B. So the PB is half of PQ, so it becomes R to P plus half of PQ. Don't it? And so we're good to go. That gives us RB. All right? Copy this down. Remove this down to the next page. Yes. Watch this now. So the RP is 3A, don't it? The RP right here, so it's 3A. And then the half of PQ is half of this. So the half of this is 4B plus 2A, don't it? Half of PQ is half of this. It's 4B plus 2A. So it becomes 3A plus, which is 4B minus 2A. Half of this is 4B minus 2A. 4B minus 2A. That's what this is. Half of PQ. Right out there. PQ, remember, 8B minus 4A. Right? So we minus ourselves. Half of it is this. Half the value. So consolidating now. So that's the simplest term now. Listen. I said this have 2A terms. They don't want it like that. Right? It's just 4B. 3A minus 2A is plus A. So it's 4B plus A is the answer right here. And the question done. And the paper done. End of this test. And that is that. Is that. I better get more than 45. On track. Better go, but all right. Remember the next paper tomorrow, gentlemen. If you never do the next paper yet, try to do before class tomorrow, please. And you guys are supposed to join the class online tomorrow. All right? If you don't join the class online tomorrow, it will be recorded. If you cannot join, it will be recorded. Make sure you go and watch the video afterwards. And Marcus said, huh? Give a Marcus sound, yeah. Give a Marcus sound. All right, everybody, online, everybody good? All right, bye. Everybody good online? Mr. Jackson, you good?
Yes, sir.
All right, good. It's all that on iPhone. I don't see a thumbs up. You do that on iPhone. No name. All right. No problem. All right, guys. So tomorrow evening again, 5 p.m. we'll do the other paper. All right. No more equal. All right. Cool. All right. Bye, everybody. I'm going to end the session now. Bye, everybody.
Yes, sir.
Yeah, man. Cool. Let's leave the start and leave. Let me sleep in. This weekend. I'm going to start our marathon sometime this weekend as well. Our revision marathon sometime. Happy by traffic. All right. Bye, everybody. One not to be on it.